So I'm going to give you a quick overview of how things cool down. So we're talking about thermal energy. A hot object has thermal energy. And how does it approach room temperature? How does it go from having a high temperature to a low temperature? So this involves 4 basic ways of energy movement, but we're going to focus on 3: radiation, convection, and conduction. And the last one, which is evaporation, we're not going to talk about that today, but it's important to bear that in mind. So convection happens when you get hot air rising. So let me just pan out here. I'm just going to give you a quick overview. So hot air is much lighter than cold air, and it's not just air, it's fluids, right, which involves liquids as well. And so basically, because a hot fluid is lighter than a cold fluid, it will move, and it will move away from the heat source, carrying that heat with it. So the hot air balloon is a perfect example of that. And the reason why hot air moves up is because as the particles get hot, as they vibrate more, they get further apart. Oops, hang on, let me sort this out. So here you can see they vibrate more. The particles are further apart, and so the air becomes less dense, or the hot fluid becomes less dense, and that floats up. Now, as it floats up, it moves away from the heat source, and the particles then become less dense. Why? Because they start to lose that energy, and they get closer together, and so they become heavier, and so they sink, right? So, for example, here we have a heat source. The air around here gets really hot, and it floats up. It's less dense than the air around it, so therefore it lifts the whole thing up. At the top, this hot air starts to cool down again, and it will come down here, and you will end up heating it up again. So you end up with a cycle. Now that is called a convection current. The fact that hot air goes up and cold air comes down, that's a continuous cycle. And that craziness happens not only on a local scale, not only in your bedroom as you put the heater on, but it also happens worldwide in terms of the world's weather patterns. So convection can be great fun, as you can see from this lantern celebration in Thailand, I think. But it's also a great way to lose heat. So if you're trying to heat something up, if you're trying to heat a room up, it's important to remember that the heat will go up and force cold air rooms. If you've got any gaps under your doors, then that heat moving up is going to suck cold air underneath the door, etc. So it's important to take these things into consideration when designing energy conservation systems in houses, etc. So on a big scale, these convection currents can cause drafts. If you're ever on the beach, for example, in the evening or in the morning, you can feel like sea breezes. And these are to do with the difference in temperature between the water, okay, and the land. We'll be looking at something called specific heat capacity a bit later on, but basically in the morning you'll find that the water's really cold compared to the land, right, which warms up really quickly. So what you end up getting is heat going up and cold air going down. So you get this breeze in from the sea, right? And then later on in the evening, it's the other way around. The water's still warm. If you're lucky, in Valencian summers, we don't often get breezes, but in the evening you should be able to feel something as that cold air comes through you, because now the land is colder than the sea, and the convection current is now towards the sea, and it's that differential in temperature caused by the convection current. And then on a worldwide scale, you can see weather patterns, and these are caused by differential temperatures on the globe. So you might find the equator is hotter, or you will find that the equator obviously is hotter than the poles, and that causes a worldwide convection current, okay, which you can see from these cloud movements. So convection is a very basic idea, but it carries over into a whole range of different contexts. Now, the second kind of energy transfer, or heat energy transfer, is through radiation, which is a really interesting one. It's a very direct way of losing energy or transferring energy, because it involves no contact whatsoever. It doesn't involve particles at all. It's dependent on an electromagnetic wave. And we get a lot of radiation from the sun because the sun is our main source of electromagnetic radiation. I'm hoping you had covered some of this before. You might know that the electromagnetic spectrum involves things like radio waves, microwaves, infrared radiation, which is the one that we are going to focus on at the moment because it's infrared. And then you've got visible light, ultraviolet, X-rays, and finally gamma rays. But this one here, this type of wave here, is called infrared, and that is a type of wave which carries heat. Or rather, it is a type of wave which we interpret as heat. And the interesting thing about radiation is that it reflects, and so the color of an object really affects its ability to be able to absorb heat using radiation or reflect it. So white houses in the summer, what they do is they reflect. In the same way white will reflect visible light. And white cars are cooler, and white containers keep things warmer because the heat inside stays inside, right? Because the radiation bounces off the sides. Whereas dark colors absorb radiation. They literally like soak it in like a sponge. And so something which is black will absorb lots of heat. And black cars are a very bad idea in Valencia because basically as it's hot outside, all that infrared radiation will be sucked in by the car. Got some pictures of a cat in here, I think. Yes, black cats are very unlucky in the summer. They do not enjoy themselves. But if you want to, say, for example, heat the water in your pool, you would use a black pipe system as a way to keep the temperature high because they'll suck that heat in. Okay, and it's a little bit like a sponge, right? So if you have heat outside and there's something cold inside, but it's in a black container, it would literally just suck the heat in. But if you have a hot object, it will lose heat very, very quickly if it's colder outside. So if you have coffee in a black cup, it will lose heat very quickly and it will cool down very fast. All right, so that is radiation. Radiation is a wave. It does not involve particles. So I'm going backwards and forwards like a crazy person. So it doesn't involve particles. It literally is nothing you can do about it. You can't stop that unless you change the color of your container. So what we're going to look at now, all of these are some infrared pictures showing you the different parts of your body and how they emit heat. And you can see, yes, the same here. That's a sponge picture. Okay, so let's fast forward because we're going to look at conduction. Now, conduction, it definitely does involve particles. And conduction is the ability of a material to lose heat or transfer heat through the material using the motion of the particles, right? So something that's made out of plastic is going to lose heat with difficulty because plastic is not very good at passing the heat on, whereas metal is very good at conducting heat. So let's have a look at a few more pictures. Okay, air is a good insulator. So anything that's got like a cushion of air is not going to transfer heat. So duvets, spongy, right? So they have air in them, and air particles do not pass heat on. Polystyrene cups are spongy. Roof insulation is spongy. A baked pavlova, which is meringue, which has lots of air bubbles. And this fluffy bird, this is what birds do in cold countries. You don't see it often in Valencia, actually. But birds literally puff up their feathers and trap loads of air between their feathers. And the air stops the heat from transferring. Whereas on the other hand, I'm going to fast forward here. If we look at, here you go, something made out of metal. So a metal container will make sure that the heat gets transferred through it very, very quickly. Most heaters or anything that you want to get hot, so an iron, you want the heat to go through the heating element through the metal here to to the clothes. The same here. These are all very, very materials that are very good at conducting heat. And the way that that happens is using this idea of transfer through particles. If you have a look at any kitchen, you probably see that all the saucepans and all your cooking appliances have metal bottoms, or if not, something like Kevlar, or materials that are really, really good at conducting heat. So conduction involves contact, right? So particles are in contact with each other and they pass the heat on from particle to particle. Convection involves gases and liquids, and it involves the movement of hot air. And radiation is always going to happen. You're always going to get a hot object giving off infrared. But if you happen to have a material which is the right color, you can prevent it. So that's an overview of conduction, convection, and radiation.